So the question here says that under the same load, wire A having length 5 meter and cross section this much stretches uniformly by the same amount as another wire B of length 6 meters, and this as the cross section stretches. Okay. So the change in length for the two wires is the same and their dimensions are different and the Young's modulus are different. So you have to find the ratio of the Young's modulus of the two wires. Okay. So basically we have to use the formula that Young's modulus is the property of the material. Okay. And this is given by stress upon strain of the material. Okay. And what is stress? The stress, the sigma here is F upon A, right? And strain is delta L upon L, right? So this is the formula that you have to use. Now for wire A, this is wire A and this is wire B, let's say. Okay. This is A, this is B. The length of wire A is 5 meters and the length of wire B is 6 meters. Area of cross section of A is 2.5 into 10 to the power minus 5 meters square, and the area of cross section of this one here is 3 into 10 to the power minus 5 meters square, right? Then you have to find the ratio of their Young's modulus. Fine. So we'll use the formula, of course. So I will say that Young's modulus of A can be written as F. They are under the same load. So the F, the force, the load is the same. So F upon the area of cross section of A is 2.5 into 10 to the power minus 5 here, and delta L upon L. So L will go in the numerator. L is 5 meters for this one. Okay. And similarly, the Young's modulus for B is the Young's modulus for B can be written as F upon the area of cross section is 3 into 10 to the power minus 5, and then upon delta L, L is 6. Okay. So the same formula I'm using here. Now I have to find their ratio, YA upon YB. Okay. So I can then write here the ratio can be given by YA upon YB is F into 5, 2.5 into 10 to the power minus 5 into delta L, and then divide by this thing, divide by YB will give you 3 into 10 to the power minus 5 into delta L upon F into 6. Okay, this thing. Now we can see that these two things are cancelling. 10 to the power 5, 10 to the power minus 5, 10 to the power minus 5 cancels. Delta L, the change in length is the same. This cancels out. The load F, this also gets cancelled out. And this 5 and 2.5, 2 here, and 3 and 6, 2 here. Then 2 and 10, 2 and 2 cancels out. So ultimately we are left with 1 upon 1. 1 upon 1. Okay. That means Young's modulus of A upon Young's modulus of B is 1 upon 1. So the ratio becomes 1 upon 1. They are the same. Okay. That means they are of the same material basically. So option number 2 here becomes the answer for this one. Okay. Thank you.